I'm so hyped. You have no idea. I've never played Fortnite in my life. And then you were like, we're making a Fortnite map. And I was like, yes. Welcome back to episode 4 of What's Up, Girl? We are so excited because this episode is literally all about Fortnite. Fortnite! I mean JoCee. No, I'm kidding. JoCee is the best, and we are so excited to have you here with us today. You're a software engineer, a newly acclaimed video game designer, and one of the coolest advocates I think I've ever met.
Thank you. That means so much. I'm so excited to be here.
So I want to start with software engineering because that is
engineering.
You the other day were trying to explain to me exactly what you do, and you were like, it's the not sexy part of software engineering.
Yeah, there's a sexy part of software engineering, I think, when you build cool things like games or web, pages and you interact with it. And then there's the non-sexy part where it's people spin up databases and spin up compute powers. I do the non-sexy part where people are just hey, I need a website. Can you spin up some servers for me that won't go down and need to handle 100 million requests over 5 seconds. And then I calculate how much compute power that is, how much RAM they need, and spin that up for them and spin it down for them when they don't need it. So I consider it the unsexy part, but it's technically interesting.
I think it was super interesting. So how did you find yourself getting into this part of software engineering?
Yeah, it wasn't chosen. I don't think I knew about it in college, right? It's not they're hey, just so you know, you can there's all these layers of technology. They're kind of just hey, here's how the internet works and build a website,
Yeah.
So I kind of just fell into it.
Does it line up with the stuff that you learned in college? Maybe tell me a little bit about kind of the degree pathway.
Yeah, I mean, computer science as a degree, I love. And I know that there's kind of a debate if you do boot camp, if you go the, you know, self-taught route, which are also great routes, or the university route. I went the university route. And I loved university for so many things. But one of the critiques about a university or a software engineering degree is that you are learning archaic languages. And that's kind of true, right? You're learning Java, you're learning C++, which now we're not even supposed to use. So it gave you the core concepts, but yeah, I had to learn these new languages, infrastructure as code is done in terraforming. It's now done in AWS specific languages. So yeah, you have to learn that on the job that you just don't get in university.
You bridged this huge gap pretty much then from what you learned in university to being able to actually support more of this heavy hitter back end stuff. What does kind of your day-to-day look like?
Yeah, so it's kind of project by project. So a lot of what I do now as I becoming more and more senior in my role is we do a lot of design and a lot of system design. So I was talking about, I deal with hundreds of thousands to millions to billions of requests, right? So building a system that can handle that and can handle that latency is where I spend probably the majority of my time and energy, just building design docs, building up small scale versions and then testing it crazy to see if it can handle that much traffic. And when it can't, be okay, that design's scrapped, start from the beginning and design again. And then so I probably spend 60 to 70% designing something. Then I go through an approval process. And then I probably spend 20% actually coding it because that's the easy part.
So you use the word design a lot. What does that actually mean? Because to me, it was so that's coding. But then you're no, 20% is coding.
This is all on a Word document. We pull in Lucid chart. It's I'll show you in our activity later. We'll build an entire game design, right? And so you're on paper designing how the system should be, what should interact with where we should cache the data, how we should store the data. Because when you're on this capacity of as much requests as it is, you need to have your database stored in a specific way. Otherwise, it takes half a second longer to get that data. Yeah. Half a second doesn't sound like much, but it kind of is when you have 1,000 requests afterwards, because now your 1,000th request has to wait 1,000 times half a second. That's 50 seconds, that's not fair to them. So now you have to really think about how you're storing things.
How do you kind of get into this what seems to be a very heavy technical mindset? Because I know you, and I know you're actually you're a very creative person.
Yeah,
that's a whole different side of what you do and what you enjoy. And do you get to apply any of that into your job? How do you? How are we using all of the sides of our brain here?
Yeah, I mean, it is like very technical, but it is very creative, right? Because like there's not like an actual solution where it's like, oh, like if I put a cache here, what does that mean? You know, it's like, oh, I'm gonna like kind of design this like system, add the cache here, the networking layer there, do this database type, and I'm gonna, you know. So it's rather creative, actually, I would say.
What is the absolute favorite thing that you like focusing your extra time on?
Yeah, so I really love to read and I really love to write, but my favorite thing is I love podcasting. And so this is like a new thing I've been doing, and I've loved it. Reading something, learning about something, and like inviting an expert to talk to them about that thing. Oh man, that's a good time. Like you're doing right now with this series. I see why you wanted to do it. It's so much fun. So I love podcasting, and I love doing that outside of work.
You have a podcast now.
I do,
yeah. So what is the podcast about, and kind of how did you come up into that?
Yeah, so like a friend was like, hey, I want to start a podcast. Like, okay, cool. And so she was an engineering manager at like big tech, and you know, I was a software engineer, so it was a very STEM focused podcast. So it's called STEM Fatale, which is a very cute name.
Yeah, it is very
cute. And that's when I like background in software engineering actually really did help, right? Like I knew the tools, like I knew what was going on. I knew how to like do like the bit conversions. I knew like I knew the technical skills necessary to learn this and how to use those applications, and like I don't know, I had such a good time.
I think one of the biggest things that I've also learned through Reinvented is that when you tell a story or you use your voice to tell a story for anything, people will come and listen. And it often only takes one person to listen and resonate for more people to come and listen and resonate, because
it just breathes. It just starts to build.
It really does. No one else can tell your story but you.
Right.
No one can do it justice. And there are so many people who don't have the exact story, but they resonate with this part of it or this part of it. And it's you standing up and talking about it that gives someone else courage to go and conquer the same challenges that your story is about.
Right. And when I talk to people on the podcast, it's like, because they ask the same thing. They're like, why should I be here? Like, I'm not rich. I'm not famous.
Right.
And it's like, but you're a human being, and that makes you so valuable and your story worthwhile and your words and thoughts important just because you exist. And you're human just like the famous person is a human.
Right.
So you are just as important as them. So you deserve to be amplified just as much. So share your story, share your thoughts, share what you're struggling with, share your world if that's what you want to do, because you're important enough to be heard.
So one of the things that when I go out and I talk to kids and I ask them, what do you want to be when you grow up? The number one answer is always a professional video game player. And I think that's great. I think it's great, right? Like you be what you want to be. But then I introduced this idea of like, have you ever considered making your own video game and being the one to program it and design it? And minds are blown. So today, our activity is actually going to be teaching all of you awesome people at home watching this how to make your own Fortnite map. So what are we doing?
Well, we are going to build an AI. So to build an AI for a video game, you want a state machine, you want an algorithm, and you want a game loop. So we have a princess in a castle trying to escape the castle. So the guards are kind of angry when she tries to escape, but if she stays in the castle, they're not angry. So they'll attack her as she gets closer to the door, but if she backs away, they'll stop attacking her. The castle's a maze. You finally make it to like the final location, the final room. And so you have a big entryway with a door. Your princess wants to escape out the door. There's a guard right here, and we have a pair of stairs and another door here. So we're gonna go here and out the door, and that's how you escape the castle.
Okay.
But our guard wants to stop us.
Right.
Okay, and the guard, again, if you stay here, the guard doesn't care. They won't attack you.
Okay.
But if you go here, the guard's gonna attack you. The guard's not a complete jerk, so he's gonna give you a warning. So if you stand here,
I appreciate that.
he's gonna be on guard. He's gonna like stand there like tough. Okay, so the guard's gonna start in a state called idle, right? And when you start a state machine, you start with a
diamond.
Rhombus. Exactly. This is how you know this is where the state starts. So this is idle. As you approach the stairs, the guard goes into a state called on guard. When you come to the door, you go to another state, attack, and then as you leave, the guard will go into a state called retreat. So those are our four states.
Makes sense.
But what if, so you come to the stairs, the guard's giving you the warning, and you leave. What state should the guard be in now? Retreat, exactly. So you're being attacked, what happens when you go right here? Where should the guard be?
Back to on guard.
Exactly, so now we have another arrow here. So this is our state machine.
Okay.
So now we need to build an algorithm. So an algorithm is basically math, right? So we need to like mathematically decide what the guard should be doing based on an input. Specifically, our input is the location of our player. And what math we're going to use is the distance from the door. Okay?
Okay.
So we have our player's position. We'll call that PP. And then we have our door position. So now we need to do math to figure out when we need to transition states here.
Okay.
So we're going to create 2 more locations. We're going to create an on guard position and an attack position. Okay. So what math do we need here? We need greater thans and less than.
Yeah.
So if our player position, PP, is greater than our on guard position, what state are we in? Retreat. So now we're going to do our player position comparison again. So if our player position is less than our on guard position and greater than our attack position, what position are we in?
On guard.
On guard. Okay. And our final one. Okay, if our player position is less than our attack position, what are we doing?
You are in.
We're attacking. That's when we get attacked. That's it. That's all the math that we need to build a pretty complex AI system. Okay, so the last thing that we need is a game loop. The game just is looping through, constantly checking where the player is and constantly checking if the player meets this math criteria.
Right.
And then it just tells the AI what to do. Okay, we're going to take all of this, put it directly into code, and you'll see how easy this is to build in code.
Okay, I'm so ready to see this code.
Okay,
Let's
so
do it.
the code's pretty simple. So I'm going to show you here. So here's our states that we talked about. Can you read them off?
Idle, on guard, attack, and retreat.
Exactly. Just the states we talked about. What we're doing here is we're kind of just like figuring out the spawn point of the AI and like where the AI is at. That's all this code is doing right here. And then we go here, and here is our game loop. Okay, so here's our code here, right? How I said it was like super simple. It's literally just loop.
It's literally exactly how you
And
read
then
it.
right here is where we sleep. So within this game loop, between the loop and sleep, is where we just check for the states and we transition states. And the code for the state is pretty simple. Just check state transition. After you do that, do your action. Here is our entire math. It is 6 lines of code right here. So here's our player position, here's our like attack position, and here's our AI position. Okay, let's see it.
Okay, testing our skills.
Okay, so here we are on the top of our castle.
Oh,
Look at the view.
it's so...
We can go around here. It's massive. So the first challenge of the map is trying to get yourself out of the castle, and it is big. Luckily, I built it, so I know the way out. Okay, so now we're here.
All right,
And-
so I recognize this. We drew this out on our chalkboard wall.
And you see our AI right there?
Yeah.
Okay, so what's he doing?
He is in idle right now.
He's in idle right now, exactly. So what should he be doing when we come over here?
Getting on the guard.
Getting on guard, just stands in front of you really tough. Okay, when I back up, what should happen?
He should retreat.
Exactly, so let's get him retreating.
Oh.
And look,
Oh,
it took me a long time to figure this out, but like he's staring at you as he retreats. He's like giving you like an evil eye. Okay, so when we get close to the door, what should happen?
He's going into attack.
He's going to attack. Okay, so he should come over here and start trying to fight us. And so we need to take him out. Oh, and he's killing us.
Oh my gosh.
So we'll go back to retreat where it's safe.
Retreating. We're retreating.
Oh, he's still. Oh no. Why is he following us? And we're dead.
We're dead.
Okay, so we were in the state attack. So we were doing this attack motion, and then afterwards we do this check state transition. Oh, I think I know the problem. Okay, so what's happening here is we are attacking, and once we finish attacking, we're gonna check state transitions. Well, that's a problem. We want him to check state transitions while he's attacking. Right, so what we actually need to do is we need to spawn right here. When you spawn a new thread, you're going to spin off a new computational unit that's going to do this thing while it's doing this thing. So now we can do both things at the exact same time. It's crazy simple, right?
It was so crazy simple. JoCee, thank you so much for being here, and thanks for helping me build my own Fortnite game. That was so much fun, and I'm so excited for all of you to join us online and play it with us. Until then, please like, comment, subscribe, and stay tuned for our next episode of
What's up, girl?